Courtney McBride, and I decided to do my video on the physics of lacrosse. Start with throwing and catching, which is also known as projectiles, and as the ball is traveling through the air, it follows a projectile motion pattern, and this is where the lacrosse ball is thrown in the air and moves along a curved path under the influence of gravity, and it sort of looks like a parabola. Potential energy is stored energy, and that would be when I'm holding the ball up here right before I'm about to throw. Kinetic energy is moving energy, and that would be when I'm throwing it. Next thing we're going to talk about is the lacrosse head, and the force of the lacrosse ball decreases when the mesh of the lacrosse head stretches. So like this. When you catch the ball, the mesh increases in surface area. This leads to more friction between the ball and the mesh. Cradling is where a player twists her wrist and forearm to keep the ball inside of the lacrosse head. This is also known as centripetal force. So you have the ball in the head and you're just trying to keep it inside so it doesn't fall out. Also, friction from the pocket and the mesh of the head help hold the ball in place. Therefore, cradling is critical to the success of a player to dodge and keep the ball in the net at all times. The next thing we're going to talk about is shooting. The further the object is from its axis of rotation, the faster its linear speed. So when you put your arms back further, the shot will be faster.
Arms and stick length act as a series of levers. As she puts her foot in the grass, friction against the ground allows her to convert her linear momentum to rotational momentum. The shot is all about speed and accuracy.
Newton has 3 laws of motion, and the first one is about inertia, and that is that an object at rest tends to stay at rest, and an object in motion tends to stay in motion until acted on by an outside force. So for example, during the draw, which is how the lacrosse game starts after shooting a goal, the lacrosse ball doesn't move until the ref blows the whistle, and then you exert an upward force on the ball to get it to go in the air. Another example of Newton's first law of motion is that a lacrosse ball will not stop moving when dropped until the friction of the grass acts upon it. Newton's second law of motion is force equals mass times acceleration. So for example, the force of a stick on a ball is equal to the mass of the stick times the acceleration of the stick. His third law of motion is all about equal and opposite forces. So for every action, there's an equal and opposite reaction. So for example, when you're colliding with someone on the field, to put it all together with throwing and catching. Got your potential energy overall, the physics of lacrosse involves throwing and catching, like projectiles. Then you get the lacrosse head, cradling, shooting, and Newton's first, second, and third law of motion.